All right, let's take a look at the example 3.1 from one of your pre-lecture videos, and let's walk through this just to double check your answers. So remember, if you feel really confident with these specific questions, you can go ahead and skip ahead and make sure you've got the right numbers and move on. But if it's maybe been a while for chemistry or you just want to see the process, definitely make sure you watch through the full video. All right, so we want to know how many of the following are contained in 100 grams of CO2, which has a molecular weight of 44.01 grams per mole. So if we want to know the number of moles of CO2, what we would do is we would take the amount, 100 grams of CO2, and what we would do is we would multiply that by molecular weight. Now we want to know moles, so that means moles needs to be on the top, grams needs to be on the bottom. So it's 44.01 gram per mole, which means that the 44.01 needs to be on the bottom. So this is an example of why we check our units. And then if we do that specific example and we calculate out, we should get 2.27 moles of CO2. And that's it. That's all there is to it. All right. So, second one is the moles of C. Now, we don't have the molecular weight of C. What we could use it, we could go find the atomic weight off the periodic table. But an even easier way of that is to look at CO2 and say, well, for every molecule of CO2 that we also have 1 mole of C because there's 1 C in CO2. So what we could actually do here is we could say, well, we just found out that we have 2.27 moles of CO2. And we know that for every 1 mole of CO2, we have 1 mole of C. So all I'm doing here is I'm using units. I'm saying this is moles of CO2, this is moles of CO2, and for every 1 mole of CO2, I have 1 mole of C. So this is effectively a conversion factor here, right? And so that's going to tell us that we also have 2.27 moles of C in our system, right? All right, let's use that same idea to look at the moles of O in the system. So we're going to start again with the 2.27 moles of CO2. And we know for every 1 mole of CO2, we are going to have 2 moles of oxygen because there are 2 oxygens for every CO2. So as a result, we're going to multiply that 2.27 times 2, and that is going to give us 4.54 moles of O. All right. Next, let's do moles of O2. All right. Well, if we have 2.27 moles of CO2, for every 1 mole of CO2, we also have 1 mole of O2. So this is slightly different here, right? We're not looking at just oxygen itself, we're looking at O2. So there's always 2 oxygens per every CO2. So just be careful there that you're watching out for those numbers. So we get the 2.27 moles of O2. All right, next, let's find the number of grams of oxygen that we have. So this time we actually need to start with a different number. Up above, we found that we have 4.54 moles of O. So let's start with that. Okay, now we want to go from moles to grams. So that means we have to multiply something that has grams on top and moles on the bottom in order to get our answer. And so in this case, what we would do is we'd go to the periodic table and we say, well, we know that there are 16.0 grams per every mole. That's the atomic weight of oxygen. All right. And if we multiply that 16 by that 4.54, we are going to get 72.64 grams of oxygen in our system. Okay, so we're just using molecular weights and atomic weights to go back and forth. Let's move on and let's look at the grams of O2 in our system. All right, well, we can do this in a couple different ways. Let's start with the fact that we know we have 2.27 moles of O2. Okay, we found that above, right up here. And we know we've got to multiply by something in terms of grams per mole. Okay, well, we know that the atomic weight of oxygen is 16, but we have two oxygens here. So this needs to be 2 times 16 to give us 32 grams per mole for O2. So that's going to tell us that we have 145.3 grams of O2. All right. Last one is to find molecules of CO2. So this one's a little different. Instead of using molecular weight, what we're actually doing here is we are looking at Avogadro's number. So we know that we have 2.27 moles of CO2. And we know that Avogadro's number is 6.02 times 10 to the 23rd. And what you have to remember here is that Avogadro's number has units of molecules per mole. So what this is doing is it's canceling out the moles and giving us a number of molecules. So if we do that math out, we learn that there are 1.4 times 10, 10, not 24, 10 to the 24th molecules of CO2. All right. So this problem is really just to review chemistry to make sure that you understand how to go from grams to mole using molecular weight. If there's any questions on this, please let me know in class. We're going to be able to do this in a lot of different problems throughout the semester, so make sure these concepts are really, really clear.